Hello everyone, my name is Xinran Hu. Today I'm going to share my project with you. My project is predicting logical pi-side index variability, modeling the influence of the climate change on forest productivity dynamics in Alberta. First, let's go through the background. As we all know, the logical pi is an important part of Alberta nature and economic landscape. In terms of ecology, it created forests that serve as homes for animals, and is also an important source for lumber for buildings, furniture, and paper goods. So what is the site index? The site index is top height at an index age, usually age 50 in northern forest in Alberta. We can see in this figure that the site index always divided into different classes. The class 1 is the highest classes, represent the highest site index and also represents the highest forest productivity. The site index can be used as a management tool to choose species for new planting areas, create management plans, and assess or forecast tree development. And these days, as we all know, the global climate change is a big problem. The rising temperatures, precipitation, and increased extreme weather events directly impact tree growth rates and health, and influencing the site index. So it is important for us to explore the relationship between the climate variables and the logical pi-site index, and how will the site index change under the climate change. So the objective of my project is exploring the relationship between logical pi-site index and climate variables, doing the geospatial site index modeling by random forest method using the climate data of 2095 plus, predicting logical pi-site index variability in 2025, 2055, and 2085 under climate change based on using the climate data of whole Alberta, and comparing the difference between the predictions of managed stand site index and nature stand site index. Next part is the method. First, let's talk about my data sources. My site index data is come from Provincial Growth and Yield Initiative. It is a dataset collects data on tree growth through the repeated measurement of permanent sample plots. And my climate data comes from the Climate AB. I used the 14 climate variables totally, and here is a table shows the full name and the acronym. Next, here are two maps about my site location. The first map is the managed stand and the second map is the nature stand. So the red, orange, gray, and black dots represent the class 4, class 3, class 2, and the class 1. And again, the class 1 is the highest class and the class 4 is the lowest class. And the other color represent the different part of the Alberta subregion. And we can find that the managed stands only have the 450 plots, but the nature stand have the 16 and 45 plots. Next part is the data exploration. First, here is a figure show the histogram of the plot site index, and the other side to make the climate data less skewed and outliers less extreme. It is necessary to do data transformation. This can bring the data closer to a normal distribution. And there are two examples about the climate variables data transformation. Next, let's go to the result part. The first result is the Julian date on which growing degree day above 5 degree reaches 100 shows the most significant correlations with other factors in the correlation matrix heat map and the PCA analysis. We can see in these two PCA analysis figures, the first one is about the managed stand and the second one is the nature stand. We can find that the degree days above 5 degree shows the important in both these two figures. The vector has the longest length and they are in the same direction of the site index. And we can also find that for the managed stand, some factors related to the heat are also important to the site index, such as the mean warmest temperature and the heat. But in the nature stand, seems like the frost-free days is another important factor to the site index, like the frost-free period and the number of the frost-free days. Here are results of the correlation matrix heat map. There are some same results as the PCA. We can find that the degree days above 5 degrees both show the highest correlation in the managed stand and the natural stand. And in the managed stand, we can also find the mean warmest temperature and the heat also show the higher correlation than other factors. And in the nature stand, the frost-free days and the number of the frost-free days shows the higher correlation than other factors. Next, I used the random forest method to do the modeling between the climate variables and the logical pi-side index. There are some statistic results. First, for the managed stand, there are some important factors which can affect the model. There are the AHM, SHM, and the mean annual precipitation. But for the nature stand, there are the precipitation as the snow, the mean summer precipitation, and the mean annual precipitation. Finally, I used the random forest model to do the prediction of the logical pi-side index. I want to know how will the side index change under the climate change in the future. So I used the climate data of the 2025, 2055, and the 2085. And this different color plots represent the plot location, and the color band represents the precipitation. And we can find that the set index of managed stand clearly shifted over time to higher set index classes, indicating that management techniques may be strengthening climate change's resilience. And the nature stand, on the other hand, show greater distribution of the site index classes, particularly in the 20 and 55. With a sizable region shifting into lower side index classes. This spread indicates that the nature stand will react differently to climate stresses, which could result in lower productivity in some places. For the conclusion, there are two key findings. First is the Julian date on which growing degree days above 5 degrees reaches 100 shows the most significant correlations with other factors in the correlation matrix heat map and PCA analysis. The second one is the managed stand site index will go to the higher site index classes, while the nature stand site index will be more decentralized and will decline to varying degrees in 2055. That's all. Thank you for the listening. And if you have any questions, feel free to ask and email me.